The queuing theory is a mathematical study of waiting lines. A decision regarding the amount of capacity to provide must be made frequently in business. It is difficult to predict about an arrival and the type of service required. Queuing theory uses models to show results within arrival, service, and departure processes. Queuing and waiting time analysis is particularly important in the service industry. The words associated with the theory are queue, which represents the number of customers waiting to be served; the customer, who is the arriving unit that requires some service to be provided. This may include people or machines. The server is one who provides the arriving customer the necessary service, and the service channel, which refers to the type of service that is provided. Queuing models calculate customer arrival, servicing, and exit. Arrivals are divided into two types: constant, which refers to an arrival time that is exactly the same time period between successful arrivals, and variable, which refers to random arrival distributions and is a much more common form of arrival. The servicing or queuing system consists of the lines and the available number of servers. Factors to consider include the line length, number of lines, and the queue priority. There are two possible outcomes after a customer is served. The customer is either satisfied or not satisfied and requires reservice. Customers demand varying degrees of service, some of which can exceed normal capacity. There are three different types of customer behavior. The first type is balking of queue. This is when customers decide last minute not to join the queue because of what they see. They do not want to be waiting in line for an insufficient amount of time. The second type is called reneging of queue. This is when customers are too impatient to wait in line. After being in queue for a while, they become impatient and decide to leave. Retrial or jockeying queue refers to the customer's response to rejoin a queue that they have left earlier due to balking or reneging. Waiting line systems can have single or multiple lines, which is how the customer gets to the server, or single or multiple servers. This means who or what provides the service. Examples include single line and a single server, like an ATM, single line and multiple servers, for instance, banks, and finally, multiple lines and multiple servers. An example of this is a fast food restaurant. As mentioned in the previous slide concerning the number of serving channels, examples of various queue configurations are shown. Single line guarantees fairness and is the most efficient setup for minimizing time in the queue. In multiple lines, service can be differentiated and the customer has more flexibility. The queuing is organized in different ways. First in and first out is the most common queue discipline. It's also known as first come, first serve. This principle states that customers are served one at a time and that the first customer that has been waiting the longest is served first. The last in first out principle also serves customers one at a time. However, the customer with the shortest waiting time will be served first. Service in random order is when a customer to enter service is randomly chosen from those customers waiting for service. And the priority queue is where customers with high priority are served first. Priority queues can be of two types: non-preemptive, which is where a job and service cannot be interrupted, and preemptive, where a job and service can be interrupted by a higher priority job. When businesses decide which queuing model to use, they must weigh the following questions. What should be the total number of service facilities to cater to the requirements of customers? How does one reduce the waiting time of customers? And what should be the ideal length of a queue, and how should it be maintained so that customers are kept happy? The objective of queuing analysis is to design systems for businesses to perform optimally, meaning maximize the profits. For example, a restaurant may be able to lower staffing costs by reducing the number of servers. This action may also increase customers waiting in line. If the waiting is too long, customers may take their business elsewhere, which will result in lower revenue. While carefully matching resources against cost, the business must also account for customer satisfaction. Long wait times impact customer satisfaction and perceived loss of value for the customer. Too many servers has an external and internal negative impact on the business. It raises costs to provide the business and in turn is passed down to the customer. This resulting effect lowers customer satisfaction. The goal is to find a perfect balance where the wait time does not lose too much value and the costs are not too high. In conclusion, it is important to look at the importance of the queuing theory and its application. Businesses often utilize queuing theory as a competitive advantage to improve customer experience. It is a practical operations management technique that is commonly used to determine staffing, scheduling, and inventory levels, and above all to improve customer satisfaction. When a system gets congested, the service delay in the system increases. A good understanding of the relationship between congestion and delay is essential for designing effective congestion control for any system. Queuing theory provides all the tools needed for this analysis. On behalf of Group 1, thank you for reviewing Project 6 and its presentation.